Alright, so in this video we're going to talk about how to graph sine and cosine functions with transformations. So there's four transformations. There's A, which is the vertical stretch, like it's been for all the graphs that we've done. And that affects the amplitude, so that affects the kind of the distance up and down from the midline that your sine or cosine graph is going to travel. Second one is your B value, which is new. We're going to talk about that one in just a minute. That's called a horizontal stretch. Notice that's a multiplier to the x versus the A, which kind of multiplies the y. Thirdly, we have this horizontal shift. Okay, so that's our C value. That's going to move the graph left or right. And then lastly, we have our plus D. That's going to be our vertical shift. That affects sort of the midline of the graph. All right, so let's take a look at this new one, this B value. Okay, so really quickly, flashback, we're just going to graph what does the graph of y equals sine x look like. Let's show you how B affects this. Okay, so if you remember when we do this, the period was 2 pi, because that's what it took you to get all the way around the unit circle. So the idea when we graph this is that we'd go out 4 tick marks, and 2 pi would be there. Because along the way, we've got those, remember, those 4 key spots. At pi over 2, we're up at 1. At pi, we're at 0. At 3 pi over 2, we're at -1. And at 2 pi, we're back to 0, and 0 started at 0. So you get a graph that looks like this. Well, what happens if we make this y equals sine of 2x? Well, when I put in 0, 2 times 0 is still 0, so the sine of 0 is 0. That point doesn't change. When I put in pi over 2, though, and I double, so this is going to be the sine of 2 times pi over 2, the 2's cancel, so it's like I'm getting the sine of pi. So even though I went over pi over 2, it's actually thinking I'm right here at this point right there, but it's going to move that point over to pi over 2. Okay, so it's going to shift that point basically to the left. So this point is now at pi over 2, 0. Well, how do I get that maximum? Well, that maximum doesn't occur anymore at pi over 2. It actually occurs at half of that value, which is pi over 4. Remember, what we do to the x's is the opposite. So instead of multiplying, we're actually dividing. So it's cutting those x's in half. So if I put in pi over 4, sine of 2 times pi over 4, that becomes sine of pi over 2, which is 1. So again, what happened is this maximum point moved halfway over, okay, or it got cut in half as far as its distance. So what's going on is I'm getting this new graph that's getting up and down twice as fast. So what that B value does is it affects the period. Okay, so we come back over here to our notes. We notice that the period, how long it takes for the graph to complete one cycle, to go up and down and back up to where it started, typically takes 2 pi, or in general it's going to take 2 pi divided by whatever this B value is. Okay? The bigger the number, the smaller the period, meaning the graph's going to go up and down a lot faster. The smaller the number, if it's like a fraction less than 1, then the graph is going to be really flat and stretched out. Okay? So that's kind of the idea of what's going on with that B value. Basically, it's saying if this is a 2, it's going to be able to create 2 full cycles in a normal 2 pi period. If it's a half, it's only going to be able to create half of the cycle. So if this was like a half, it would be like just this. It would be this kind of flattened, stretched out piece. So I'd only get like half of the full graph in the normal period. Alright, so let's take a look in graph 1. Alright, so we're going to graph y equals 2 sine of x minus pi over 4 minus 1. Step 1 is going to be able to find the period. Okay, so again, our period is equal to 2 pi divided by b. And our b value would be the number in front of the x. There isn't one, so it's implied that it's the number 1. So I get 2 pi divided by 1, or 2 pi. So this is a typical graph. Okay? So once I find that period, Remember, in one full period, the graph is going to go up to a max, to a midline, down to the minimum, back to the midline. It's going to get that full cycle for a sine graph. Sine graph is going to look like this. If it's a cosine graph, one full period, that's not a very good graph, but it's going to look something like that. That's not the best cosine graph, but hopefully you kind of get the idea. It's going to go from a max to a max. So what I'm going to do, once I find my period, is I'm going to come over here and I'm going to use the idea of that there's four things happening in one full period. Okay, it's going to get up to a max, midline, minimum, and back to the midline for a sine graph. So I'm going to come out and I'm going to make 4 tick marks, and I'm going to label the last tick mark whatever my period is. So in this case, my period was 2 pi, so that's what I'm going to put at my 4th tick mark. If my period was pi, I'd put pi at my 4th tick mark. If my period was 4 pi, I'd put 4 pi at my tick mark. Now I just got to figure out how much each tick mark is then worth. So, well, there's a middle one, so that should be half of the full period, which is pi. And then there's one in the middle of that, so that'd be half of that, which is pi over 2. So each tick mark is pi over 2. So that's 1 pi over 2, 2 of them. This should be 3 pi over 2. And these are those kind of maxes and midline and minimums on the unit circle. And let's just go to the negatives as well. So I've got negative 2 pi, negative 3 pi over 2, negative pi, and negative pi over 2. All right, so step 1 is to find my period. Go to 4 tick marks, put whatever your period is there, and then kind of figure out what each tick mark is worth. Next thing I'm going to come back and do is look at my range. Okay, I find my range by looking at my 2 vertical transformations. The midline, so the middle of the graph is at negative 1, and then the amplitude tells me how far up and down I travel from the midline to find my maximum and my minimum of my graph. So I'm going to start at negative 1 and go up 2. So the highest I ever get is 1. And from negative 1, I'm going to go down 2, so the lowest I'm going to get to is negative 3. So my range is from negative 3 to 1. Now, I'm personally going to come in here and plot that out. So here's 1, here's negative 1, negative 2, and that was not a good spot. And then here would be negative 3. All right. So let's see that. Yep, negative 3 to 1 is what I wanted. Just wanted to make sure. So the highest my graph ever gets, and I'm just going to kind of dash in these spots. You don't have to do this. It just gives me a nice idea of where my graph is. I'm dashing in the 3 key spots that we're going to graph. The maximum, the midline, and the minimum. All right, so I know my graph is going to be contained in that kind of horizontal boxes that I've kind of set up. All right, so I know that. Last thing I'm going to focus in on, focus 3, is on what function it is. Actually, maybe second to last, is the sine function. Okay. Now, sine graphs start at the midline. Sine starts at midline, whereas cosine graphs start at a maximum. All right, so I'm going to graph a sine graph now, with the period change, which there wasn't one, and the new max and mins. All right, so what does this graph look like? Well, it's a sine graph. So we said it's going to start at the midline, which is right here. And then a sine graph goes up. So at the next tick mark, I should be up at a maximum. The next tick mark back to the midline. Next tick mark at a minimum. Next tick mark at the midline. Next tick mark would be here. I'd be up back at the max. Next one would be at the midline and at the minimum. Up, down, up, down. I'm going to do it in the negatives as well. So down here, here, up here, and back to the midline. All right. Now that is the graph of everything except my final piece, which is this horizontal shift. So the last thing I need to do is just apply this horizontal shift and move the graph to the right, because it's minus. So the fourth thing I want to do is my shift, and it's right pi over 4. All right, so I'm going to come back over here. I'm going to move every single point to the right pi over 4. I got to figure out how much is that. Well, 2 tick marks is pi over 2, and half of pi over 2 is pi over 4. So it ends up being kind of one box. So I'm going to move every point to the right, one box. So every point is now getting shifted over to the right, one box, shifted to the right, pi over 4. So I'm going to get that exact same looking graph. There it is. So this yellow graph, this is my final y equals graph. Okay, so this is the winner. This is the one that I want. Okay. So again, there's multiple ways to kind of do this, but I think the biggest one, the easiest one would be kind of the route that we're teaching you. Find that period, make that 4 tick marks. Again, why 4 tick marks? Because on a unit circle, okay, we started here, then the next critical point's up here, and then here, and then here, and then back there. Okay, so there's that max and midline and minimum, and then back to the midline. Kind of gets me that one full cycle, and then I just, repeat and keep going around and around and around. So once I've found that period, then the next big thing is to figure out that range, which again uses the midline and the amplitude, the 2 vertical transformations, the vertical shift and the vertical stretch. Figure out what the max is and the min is on your graph. Again, I like to kind of dash in, or at least somehow, highlight on your y-axis sort of the 3 critical heights so you can kind of plot them correctly. Then I would graph a sine or a cosine. Since it was a sine, I started at the midline, and then the next key point would be the max, and then the midline, and then the min. If it was a cosine graph, I would have started up here at the maximum, and then went down and made my graph from there. And if it was a negative, there's some reflections and stuff like that. You might see those in some more examples. Okay, so that's kind of one example of how to do that. We've got a second video up as well on the website that'll show you 2 more examples as well. Again, if this doesn't make sense, I've got a few other ways to teach you how to graph as well, so just seek myself, Mr. Krenz, or whoever your teacher is out to see some other examples.